In lesson 4.3, we're going to look at how to find the values of trigonometric functions. And one way is through using geometry. And then we also use the calculator. And we're going to also talk about inverse trig functions and how accurate we need to express these answers, as well as reciprocal functions. So let's go back and review briefly about geometry. In geometry, if I start over here on the left-hand side with this equilateral triangle, if I drop an altitude from one vertex to the opposite side, what happens is we divide this into two right triangles that are 30 and 60 degree angle measures for the acute angles. And the relationships between the sides are this. If the hypotenuse of this triangle on the right is 2, then the short leg opposite the 30 degrees is 1, and the long leg opposite the 60 degrees is the square root of 3. Now, using that fact, we can say, oh, the sine of that angle theta, if theta is 30 degrees, let's look at this 30-degree angle up here, is going to be opposite over hypotenuse. So the sine of 30 degrees is 1/2. And the cosine of that 30 degrees is adjacent over hypotenuse. So that's the square root of 3 over 2. And then the tangent is just opposite over adjacent. So the tangent of 30 degrees is 1 over the square root of 3. And we could rationalize that if we wanted to. 60 degrees, looking at the same thing here. The sine of 60 degrees is opposite over hypotenuse. That's over here in our chart. The cosine of 60 is adjacent over hypotenuse, which is over here at 1/2. And then the tangent of 60 degrees is opposite over adjacent, which is square root of 3. Now for a 45-degree angle, we go back and think of a square and draw in a diagonal. And we have this isosceles right triangle that's formed. So these two angles here are 45 degrees each. The two legs are 1 each, and we can use the Pythagorean theorem to find the missing hypotenuse here is square root of 2. And then we use the same procedure. When I'm focusing on the 45-degree angle, the sine is opposite over hypotenuse. Notice that's 1 over square root of 2. The cosine of this 45-degree angle is adjacent over hypotenuse, 1 over the square root of 2. And the tangent of 45 degrees is opposite over adjacent, which is 1. Now, these are trig functions of 3 angles that are used quite a bit in trigonometry. And there's even a little note here. It's helpful to be familiar with these because they're going to be used in later sections as well. So I would keep this somewhere in my notes, this little table of values here for the 30, 45, and 60-degree angles. Now, if we're trying to find values, now all those answers were exact answers. If we're trying to find values from a calculator, they're going to be rounded. Like if we use a calculator to find the value of the tangent of 67.36 degrees, first of all, we got to make sure that the mode of the calculator is in degrees, okay? Make sure that's highlighted. And then we type in tangent of 67.36. You don't have to put the degree symbol down because the mode is in degrees. This would be your answer. There's also another important function on your calculator, which is an inverse trig function. And to use that, we're using on the calculator, on the display, it's above the sine, the cosine, and tangent. And it looks like this. The inverse of sine is the sine -1x. That's not raised to the -1 power. This is the inverse of the sine function, which means you know what the sine of an angle is, and I'm trying to figure out the angle. So I want to work in reverse. Or maybe I know the cosine of an angle, but now I want to figure out what the angle x is. Okay? So it's not a negative exponent. So we want to be careful that we don't think that that's a negative exponent. It's just saying we're working in reverse and finding angle measures. So To find this inverse sine key, we just press second sine, and that key is going to come up. Okay, and another notation you might see in other textbooks is arc sine. This one is going to use inverse sine function. Okay, so let's look at a problem. Here we're asked to find the value of the sine of 12.5 degrees. And this table is given in your e-text, how many decimal places, or how many significant digits rather, that you need to express your answer. So if the measure of the angle is in degrees only, then you just go 2 significant digits. If it's tenth of degrees or if it's in minutes, then you need to go 3 significant digits. If it's hundredths of degrees or 1 minute, then you need to be looking at 4 significant digits. So the first one, find the value of the sine of 12.5 degrees. So we make sure our calculator is in degree mode, and then we're just going to type in the sine of 12.5. That's our answer. Since this is to the nearest tenth of a degree, since we're working with that, we want to express our answer to 3 significant digits. So we're going to take this 0.21643 blah, 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 and round it off, and it's to 0.216, 3 significant digits. To find the angle, if the tangent of an angle is 1.039, now look, we're looking for the angle. So to find the angle, we need to use our inverse function. So we're doing second tangent, and we're still in degree mode, typing in that number. We're going to get this answer. Now, here we're going to express this to 4 significant digits, because notice that this is out to, this is 1.039. So we want to make sure we've got at least that many significant digits, 4 significant digits. So it's 46 point, and this rounds up to 10. The reciprocal functions on your calculator, there's not a key for cotangent or cosecant or secant. You just need to know cotangent is the reciprocal of tangent. And I would suggest using this first technique here, 1 divided by the tangent of the angle. I would not do this because it's real easy to confuse this with inverse function. So let's just do 1 divided by the tangent. That gives us the reciprocal. If we're given a function and we want to find the theta, find the angle, that's when we use the inverse function. So cosecant is the reciprocal of sine. Okay, so we're going to take the reciprocal of that and use the inverse function. And we round this off to 4 significant digits. If sine theta, or if we're asked to find the sine theta, given the tangent of theta. Now notice how this is worked out. If the tangent of theta is 1.936, to find theta, we'd have to take the inverse tangent, right? We're still working in degree mode. And then to find the sine of that angle, I do the same thing to both sides. So this is what I'm going to plug into my calculator. The sine of the inverse tangent of 1.936. And then I would express this to 4 significant digits.